There's a special formula called the small change formula. Let's go back and think about what the definition of what dy dx is. And if we've got a curve, you know that dy dx is the gradient. The gradient function, if you like. So if you know what y is, you can find dy dx, and that'll give you the gradient at every point along the curve. If we go back to what the definition is, we can say that dy dx equals the limit as delta x approaches 0 of delta y over delta x. Now, graphically, what does that look like? If you've got a point P here and it has the coordinates x, y, and you've got a point Q, that'll be x plus delta x, y plus delta y. So in other words, the distance from there to there will be delta x, so that's delta x, and the distance from there to there will be delta y. So you know that gradient is rise over run, so here is my rise, which is delta y, and here is my run, which is delta x. So as delta x gets smaller, in other words, as q moves closer and closer along here towards point P, we get the secant, which is the line that draws a straight line that connects point P to point Q. As q moves closer and closer, the secant gets closer and closer. Let's just do it in another colour here. There's the tangent at point P. But this secant, this purple secant, the straight line that joins P and Q, will get closer and closer and closer to the green line as delta x approaches 0. Now, if delta x is small, then dy dx is approximately equal to, now there are two symbols for approximately equal to, you can either use that one or that one, so both of those mean approximately equals. So an equal sign with a dot above and below, or just a squiggly equal sign. So dy dx is approximately equal to delta y on delta x. So we're saying that the gradient is, if delta x is very small, or quite small, delta y and delta x will give you approximately the same value as the gradient. This can be rearranged, and so you can multiply both sides by delta x, and we'll be left here with delta y. So you get delta y is approximately equal to delta x times dy dx. Now this is what we know as the small change formula. And what it does is that given some small increment of x, and if we know the function, we can actually find out the corresponding small change in y by finding dy dx, multiplying it by delta x, or the change in x. That'll give us the corresponding value, the corresponding change in the y value. All right, so next video I'll come back and do a little example on how we're going to use that.